A penny, a nickel, a dime, and a quarter are tossed. What is the probability of obtaining at most 2 heads on the tosses? This is a difficult and a long problem. You can see I've already made the tree for you. Let me explain why we make a tree. How do you know when you read a word problem that you're supposed to make a tree? Well, when there is more than one action happening, more than one action, let's say it this way. Whoops. More than one action. So you have the first action and the second action and the third action, etc. So when you have more than one action and there's an and between them, the first action happens and then the second and then the third, in that case you need to make a tree. The tree shows the branching of the actions. So you can see the tree I've made down here for the action. So the first action is we're going to flip a penny, then we're going to flip a nickel, then we're going to flip a dime, then we're going to flip a quarter. That's 4 separate actions, and each of those results in a branching. So here's the branching for the penny. Right? The penny's going to result in heads or tails. It's the first action. Next action is the nickel. It's going to result in heads or tails. That's the second action, second layer of branching. Third action, the dime, is going to result in heads or tails. If you can come down here, it's this whole level of branching all the way down here is for the dime. And then finally, the quarter. The quarter, right here, heads or tails, heads or tails, heads or tails. All this branching is for the flipping of the quarter. So there's all that branching. So that's the fourth action, the fourth layer of branching. So, now, and then what's the result of all that? Well, you can see at the ends, I've got the results. Now, how did I get this head, 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 head? I just followed the branching, starting here at the beginning. A head was flipped on the penny, then a head was flipped on the nickel, then a head was flipped on the dime, then a head was flipped on the quarter, head, 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 and then what's the probability of that? Well, each of those branches is a half. So it's a half times a half times a half times a half, which is 1/16. So that's how I got that answer. And then I followed each of those in the same way. So for the next, so what I did not write, I guess one thing I did skip is the diagram just got too cluttered. I should have really written a half on each of these branches, because the chance of flipping a head or a tail on any of these coins is a half. So really there should have been halves written on all these branches. Let me do that. Just gets kind of cluttered here. So there we go. And so then I went through all the various possible endings. So I got this first one, 4 heads, and then I did the next one. I just did head, 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 tail. See that? Head, 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 tail. Head, 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 tail. That's how I got that result right there. I just followed the road to that end point, and that led to head, 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 tail. 3 heads and a tail. And of course that's going to be 1/16 as well. They're all going to be 1/16 because they're all a half times a half times a half times a half 4 times, which is 1/16. So, and then I just kept doing that for the other branches. So how did I get this one? I just followed head, head, tail, head. Head, head, tail, head. I wrote head, head, tail, head, and it's 1/16, etc. So I just figured all the ins out. So this is a complex one. This might be a good diagram to put right on your notes for the next exam. Okay, so now let's get to the actual question. What is their actual question? Coming up here. What is the probability of obtaining at most 2 heads? Now there's different versions of this question on the homework. This is the most complex version. I thought I would just do the hardest version from all the versions I've seen, and that should take care of it. So what's the probability of getting at most 2 heads? At most 2 heads. So first off, you got to be clear, what does at most 2 heads mean? It means 2 heads, or 1 head, or 0 heads. At most. That means the most is 2. It could be 2, 1, or 0. So that means 0, well, that means 2, 1, or 0 heads. That's what they're saying. What's the probability of getting 2, 1, or 0 heads? At the most, 2. So we got to go up here, and then we're going to have to highlight every answer that has 2, 1, or 0 heads. So here we go. 2, 1, or 0 heads. So does this have 2 heads? 2, 1, or 0? No, that is 4. Does this have 2, 1, or 0? No, it has 3. Does this have 2, 1, or 0 heads? No, it has 3. Does this have 2, 1, or 0 heads? Yeah, it's got 2. So there we go. 2 heads, 1/16. The next one, 2 heads, 1/16. 2 heads, 1/16. 1 head that's 2, 1, or 0, we'll take it. 3 heads, no. 2 heads, 1/16. 2 heads, 1/16. 1 head, that works. 2, 1, or 0 heads. 2 heads, that works. 1 head, that works. 1 head, that works. No heads, 2, 1, or 0 heads, we'll take it. So we're going to take all of those. So how many is that? How many did we shade? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 sixteenths, because they're all 1/16 added up. So 11 of those is 11 sixteenths. Oops. And that's the answer to the question. 11, let me do that a little better. 11 sixteenths is our answer. Now, if they have other versions, they do. They have other versions. Sometimes they might say, what's the chance of exactly 2 heads? So you would just count the ones that had exactly 2 heads instead of the ones that had 2, 1, or 0, because they said at most 2 heads, which is different than exactly 2 heads, right? At most is 2, 1, or 0. Exactly is exactly 2. They might say at most 1 head. Then you would do the ones that had 1 head or no heads. They might say exactly 3 heads. Whatever they say, just count up the endings, and it's that many over 16. So there we go.